The topic of today will be about equality. So let's have a look at the history of the equal symbol. So it was introduced by Robert Ricord in 1557 to avoid to write is equal to in letter when doing computations. So for him, the two lines of equal length and same orientation was equivalent to saying that things were equal. So let's have a quick view with an intuitive definition. So an equality expresses the equivalence between two terms. So basically what it means is that when you see the equal sign, then you have the left side and the right side. Well, this symbol means that these two expressions are equivalent. So an equality can appear in different contexts. For example, it can appear for an affirmation, for a notation definition, or an equation. So the three cases that we just mentioned will be described in the following minutes. So now let's have a look at an affirmation. So let A and B be some real numbers, then we have the following identity. So remember, this identity is true for any pair of A and B. It's not a solution of an equation which is only true for some numbers. So on the left hand side we got a plus b squared, and on the right hand side we got a squared plus b squared plus 2ab. So this is an affirmation because it is always true, and then now you can see that both sides should be equivalent. Now an example of a notation definition. So let f be a function that takes some real number and outputs some real number. Then the function defined by f of x equal to a times x squared plus bx plus c, where a, b, and c are some real numbers. So this is a quadratic function. So this function has at least one zero if the discriminant, which is written as delta, equal to b2 minus 4ac. If it is greater than 0 or equal to 0, then we have at least 1 0. So basically here, if you check the delta, this is the important element that I want you to notice. So this element has been defined. We choose to name this quantity as delta. So basically this is a notation. And if you don't remember where it comes from, then you can see below how the formula to find the zeros. Last but not least, an example of an equation. So the first equation on the Ricord notation. So Ricord is the guy which we saw earlier, remember? So the first equation that he wrote in his book was 14x plus 15 is equal to 71. So for this expression, we only have one solution. So this is not like an identity that we saw earlier. So now we are at the key part of the video. So let's talk about the substitution rule. So these rules say that for all quantity a and b, and for every expression f of x, if a is equal to b, then we can just apply the function f on both sides of the equation. If, of course, f of a and f of b are well defined. So this is really important. This is a really general rule, and knowing this rule will allow us to work on some particular cases that are really useful for algebraic manipulation. So now let's have a look at these particular cases of the substitution rule. So there are 4 cases that are really interesting for us. Let's have a look at the first one. F of x is equal to x plus c. So let a, b, and c be real numbers, and if a is equal to b, then we have that f of a is equal to f of b. So basically what is interesting is that if you check, you can see that a plus c is equal to b plus c. So what did we do? We just add c on both sides of the equation. So that is really interesting property for us. Now the same logic can be applied for the following function. F of x is equal to x minus c. Then what you have is a minus c is equal to b minus c. So you can just subtract on both sides of the equation. And then after that you can do f of x is equal to cx, and then you have ca equals cb. You can just multiply by a scalar on both sides, and then finally you can also divide on both sides of the equation. However, when you divide on both sides of the equation, you have to make sure that it's different from 0. Otherwise, the expression are not well defined. I know I already told you guys in the previous scene, but please don't divide by 0. You cannot divide by 0. This is illegal. You can be arrested for this. So basically I won't describe why, because it will lead us too far, but basically there are some contradictions in arithmetics if you try to divide by 0. So please don't do that. Let's do a simple exercise with one equation and one unknown. So basically we will check the equation of record that we saw earlier. So pause the video and try to find x. So if you found it, congratulations, and if you didn't find it, no problem. The answer is x is equal to 4. So in the next scene we'll do it together. Now let's solve this problem together. So the equation is 14x is equal plus 15 is equal to 71. What we can do is put the x on the one side and put the constant on the other side. So we have 71 minus 15. So you can simplify that. It's 56. And now what you can do is divide both sides by 14. And then what you got is x is equal to 4. Let's do an exercise which is more complex. 2 equations, 2 unknowns. So pause the video and try to find x and y. So if you found it, congratulations, you remember well your high school math. So the answer is x is equal to 4 and y is equal to minus 5. So again, we will do this exercise together in the next scene. Okay, let's start. 2 equations, 2 unknown. Let's try to solve this. So what we're going to do is we're going to modify the 2 equations and then we'll add them together. So let's modify the first one. So equation 1 is equal to minus 3 times equation 1. So now you can see it becomes minus 9x plus 12y is equal to minus 96. Now you do an operation similar for the second equation. You multiply it by 2. You have 14x minus 12y is equal to 116. And now what you can do is just add these 2 equations and then the y just disappears. So by adding them up, you obtain 5x plus 0y is equal to 20. So now you can just isolate x and you obtain x is equal to 4. Now we need the value of y. So what you can just do is substitute back this value in one of the 2 original equations or one of the 2 equations that we just modified. So if you substitute this value in the original equation 1, then you obtain 3 times 4 minus 4 times y is equal to 32. And then you can just divide both sides by minus 4. And what do you obtain? Y is equal to minus 5.